Next in this session, we'll see looping statements. So why do we need looping statements? First, we'll see the fundamental need of a loops in the C program. Loops are used to execute tasks repeatedly. Yep. So there are scenarios or there are logics where you need to execute certain set of tasks in a cyclic fashion. Meaning, say every 1 second you want to do something, every 10 milliseconds you want to do something. So those can be achieved using the looping statements. And there are to achieve this, I mean, C is a syntax-oriented program, so there are some syntaxes or expressions which are used or which are available in C program. So that's for loop, while loop, do while. Okay, so these three are the basic set of looping statements extensively used in C program according to the different needs. Yeah, and each one will vary slightly in a different way, apart from the name itself, the for, while, and do while. So the concept of each has a little variance in it. So next we'll see the flow diagram. Yeah. So this is a standard flow diagram I have drawn here. So this diamond indicates it's a condition. Okay, if true, false, correct, can either be true or false. But whereas these boxes indicate a plain statement, there is no true and all. I mean, there is no if condition. It's like A equal to B plus C. So that is what it is, or these things. So there is a start point for every loop. Okay, you enter a loop with the initial value. Then there is a cycle because you're looping for a certain number of time or for a certain amount of time. And that amount of time, or not only time, we can also loop it till a condition is met. Okay, we say, for example, you are monitoring a level of a water tank, and then you have to loop till the water tank is filled to certain level. So that is this condition. Okay, so if the condition is met, then I'll execute a statement, and then increment or decrement, meaning this condition, the for loop, we'll see later when we actually write a C program, the significance of increment or decrement. Meaning we are constantly feeding an information again to the condition. Yeah, there is an initial value, and that initial value will either get incremented or decremented, and that will be checked against a fixed end point, whether we are reaching or not. If we reach the end point, we come to the else block, and we end and exit the loop, exit the for loop. So in the for loop, we have this increment and decrement. So that's where, say you want to loop something for 100 times alternately, that can be done using for loop. We'll see all this in the coding examples. Okay. And next we have while and do while. So I've not added a lot of content explanation because a lot will be explained in the C codes. But whereas this flow diagram is very important to understand the fundamental differences. Okay, so there is a while loop, and this is the entry to the loop. Okay, so you see here there is no initial value. There is directly a condition is being checked. Okay, this condition is true, then execute statement. After executing the statement, again go and check the condition. Condition is true. As long as the condition is true, keep executing the statement. The moment condition becomes false, you're exiting the loop. Okay, so the execution of the statement happens only if the condition is true. Correct? Not even once this will execute without condition being false. But whereas this side is the do while loop, which is below this. Yeah? There is an entry. As soon as you enter, you do certain tasks. That's why it's do while. First you do it, then condition, and next time onwards, in the second iteration onwards, if the condition is true, only then the statement is executed. Otherwise, it exits the loop. Both are same, except that the statement here definitely executes for once in the do while. Irrespective of condition being true or false, it will definitely execute here. But whereas here, it won't execute as long as condition is false. Let's see how to use a for loop in the code. So first we'll take a very simple example of just to demonstrate looping. So I use a iteration variable I. I mean, you can name it anything, but I use I throughout the program for a looping condition throughout the session. And this is a for. What we have initially is an initial value. Start from 0, then a condition less than 10, then increment or decrement. Let's increment here because we are going from 0 to 10. Okay. Now, just simply to demonstrate looping, let me loop it like this. Looping for, and I print I itself. Okay. So here, what I'm trying to show is that we enter the for, and there is the initial condition. Initially I equal to 0. Is I 0 less than 10? Yes, it will enter. Okay. So let's compile and see what it produces as output. Okay. So it has produced one after the other. So for better representation, let me add a new line. Yeah. So here we have looping for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So 9 times it has iterated. Because every time if we see iteration by iteration, I first, initially it will be 0. I is 0 is less than 10. Yes, it will come inside, print the first statement. Then I plus plus. Okay. So now next time when it comes here, I initial value is already done. So it won't initialize it again. So I 1, I has become 1. Is 1 less than 10? Yes. Similar is, it will go on incrementing till 9. Okay. Is 9 less than 10? Yes. Next time it will become 10. 10 less than 10? No. 10 actually equal to 10. So this condition becomes false. It will exit the loop. Okay. So this is the not very basic demonstration of a for loop. Yeah. So like we saw in the previous slides that we can do it alternately. Okay. So let me show you there are two ways how we can achieve it alternately. I'll just change the increment. What I'll do it I plus 2. Okay. So we'll see the output and try to understand the code in itself using the output. Okay. So I just did a slight change in the increment or decrement part of the for loop. That is the third one. I incremented it by 2. Okay. There is no necessary that you always have to increment it by 1 or decrement. It can be anything. You can increment, you can divide it also. Okay. So then this for loop starts from 0, 0 less than 10. Yes, print it. Next I becomes 2 because I is equal to I plus 2. Then it will come again. It will till 8 it will execute. Okay. So that's why you're seeing 0, 2, 4, 6, 8 are being printed. That's because we're incrementing by 2. Okay. Say you can say that no, I still want to increment it by 1, but I want it to happen alternately. In that case, we have to use if. Okay. So then what I'll do, we want to do it alternately. So I'll use this reminder operation. If this is completely divisible by 2, only then I would like to print. Okay. See, even though we are incrementing it by 1, what we added a condition here is I, that is 0. If you divide by 2, the remainder is 0. 1 divided by 2 remainder is 1. So 1 is not here. So this is another way of achieving. So here we are mixing for and if. So this is also possible. We can use if inside, for inside a if. So there is no supersedence or for is not superior to if. Both are at same level or both are similar expressions. It's not always that if has to be within for. It's the other way around is also possible. We'll see one more example. So what we saw is for and if condition. Now we'll try to use the nested for. Okay, so here I want to attach some uh, program to this or a logic to this. I want to print certain set of strings or certain pattern of a string. Okay, so for that, I'll try to define one more variable j. I will go through the code. Yeah, for j equal to, again there is an initial value. This time I want to limit j to the value of I, which is present. Okay, then j plus plus, and I want to print star. Okay, every time the j is executed, I want to print star here. And after the complete inner for loop is done, I want it to go to a new line and start doing same activity for a new line in this for. Okay, so there are two fors, so it's like a two-dimensional thing. One is the outer for. So in this for, we are defining the number of iterations. So if we go through this code, then there will be 10 new line characters. Okay, but before a new line character, we want to do certain set of tasks again in one more loop. That is this. We'll see the output, what kind of output it produces. Sorry, there is semicolon missing here. This is the kind of output it has produced, and yeah, this is what I wanted to print as well. Because in the first iteration, I is 0, okay, 0 less than 0. I think that's why the very first statement is empty. Okay, so at the end, how many stars we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 stars we have. So the 0th iteration is gone. That's why there is no number. 0 less than 0. Just to double check, it's not printing 0 for sure, or 0th iteration is not considered at all. Expecting it to start printing from 1 till 9. Yeah, that's what has happened, 1 till 9. Okay, so earlier there was one string. The 0th iteration is not executed for I being 0 because j is also 0. So that's why we have j 0 less than 0, not true, it will come out. So from 1 it has started and all the way printed till 9. So this is a way how we can use the nested for, or we can say a two-dimensional for. Okay, there is one dimension and there is another dimension. Row is one, this is all related to row, and this is for the column. Correct? This is for column and this is for row. So sort of two-dimensional activity is achieved in this. Yeah, let's see how to use break statement in this case. Last time what we saw is we used a break statement in a switch decision making statement, and there is a wider scope for break statement. I mean, that can, how efficiently we can use break in the for and make the code more efficient. Okay, so what I meant by more efficient, meaning, so if you see a for loop, it's looping and executing a bunch of statements in repeat order. Okay. The moment you add 1 million here, what is going to happen? That it's going to iterate here for 1 million times. Okay, so it's a lot of time being wasted in the execution. Not wasted, it's a lot of time being spent in this execution. But there are some cases where we want to search a string from a wide range of database. Correct? So we'll take that example. So say we're iterating from 1 to 10, and I want to capture 3 here. Okay, what I'll do is I equal to 3, I'll print value of I is and I break. Okay, if I break it, it's directly going to come here. Okay, then what I'll do, I'll make j equal to I plus 1 just to show where it has left. Printf okay. So what I'm trying to demonstrate here is I'm iterating from 0 to 10. The moment I find I print this. Okay. So what happens if I don't write the break statement? It will keep iterating here, even though we have achieved our purpose of this for loop. Okay. So I have used break now, and then it will break after 3 iterations. Out of 10, after 3 iterations, it will come out of 4. So here we are efficiently saving 7 iterations unnecessarily. I using the term unnecessarily because the purpose of the for loop is this. Okay, the moment this is done, if I don't write break, it will still keep executing where I is no more 3 cannot become 3 because this condition has already become true, and in the later cases it might become false, though it will print the statement. Yeah, it will unnecessarily execute. Let's see, that's what I have taken a new variable j to show what is the value of j. I'll build it. See, value of I is 3 because so for j to be 4, it has to exit this loop when I is 3. Okay. We'll see what happens if I don't use a break statement. It's still going to print this, but it will iterate till 10, till I becomes 10. That's why you're seeing j equal to 11. That's where I made a decision to use a break statement. The moment I find the purpose of this for loop is done and I want to break out of the loop. Okay, so it will simply, though this is within the scope, it will break out of a loop. So in this way, we can save a lot of iteration and reiterations. It is 10. Say if I have 100 here, then it's going to save 97 iterations.